Using the law of sines, we need to show that in a triangle ABC, tangent of A over 2 plus tangent of B over 2 divided by tangent of A over 2 minus tangent of B over 2, that's equals to C over A minus B. Okay, let us begin. So we'll start from the left hand side. So we can rewrite the left hand side as the tangent can be converted to its equivalent ratio of sine over cosine. So we have sine A over 2 divided by cosine of A over 2 plus tangent of B over 2 can be rewritten as tangent of B over 2 divided by cosine of B over 2 whole divided by sine A over 2 multiplied to cosine of A over 2 minus sine of B over 2 divided by cosine of B over 2. Fine. Now what we'll do, we'll combine the two fractions in the numerator. So that gives us sine A over 2 times cosine of B over 2 plus cosine of A over 2 multiplied to sine of B over 2 whole divided by, so we have a common denominator in both the numerator and the denominator, which is cosine A over 2 times cosine B over 2. So that gets factored away. So we have sine A over 2 multiplied to cosine of B over 2 minus cosine of A over 2 times sine of B over 2. Right. Now this is the expansion of sine A over 2 plus B over 2, and the denominator, that's the expansion of sine A over 2 minus B over 2. Fine. So what we'll do, we will multiply both numerator and the denominator with 2 times cosine of A over 2 plus B over 2. So 2 times cosine of A over 2 plus B over 2, this will get multiplied to sine of A over 2 plus B over 2 whole divided by, we have 2 times cosine of A over 2 plus B over 2 multiplied to sine of A over 2 minus B over 2. Now we have an identity in the numerator as well as in the denominator. So the numerator is 2 times cosine theta times sine theta. Let me note it here. So we have 2 times sine theta times cosine theta in the numerator, which will be cosine of 2 theta. And in the denominator, we have 2 times cosine of A plus B over 2 multiplied to sine of A minus B over 2. So that is actually sine of A minus sine of B. So let's replace this value here. So that means our numerator will now become sine 2 times, we have A plus B over 2 whole divided by sine, we have sine A minus sine B. That gives us sine of A plus B whole divided by sine of A minus sine of B. Now we also know for a fact that in the triangle ABC, the sum of the interior angle, that means A plus B plus C, it sums up to pi radians. So that means we can rewrite it as A plus B as A pi minus C. If we take the sine on both sides, so we have sine of A plus B, so that will be equals to sine of pi minus C. What's the value of sine pi minus C? So that's simply sine C. So we have sine A plus B, that will be equals to sine C. Now we can replace the numerator portion with sine C. So we're going to get sine C whole divided by sine A minus sine B. Now let's use the law of sines. Now that we have simplified it, so using the law of sines, we know that if we have a triangle ABC where the letter A, B and C in lowercase represents the side opposite to angle A, B and C respectively. So here the law of sine simply states that the ratio of side A to that of sine of the angle opposite to side A, so that will be angle A, thus equals to side B, the ratio of side B to that of sine of the angle opposite to side B. So this is angle B, and this will be equals to the ratio of C to that of sine of the angle opposite to it. So this is the law of sine. So if we consider that these two ratios are equals to some constant 1 over lambda, then we can rewrite sine A as lambda times A. Sine B will then be equivalent to lambda times B, and sine C will be equivalent to lambda times C. So we will use these three values and replace it back in our final result. So we have sine C over sine A minus sine B. So we're going to get lambda C divided by lambda A minus lambda B. We can factor out lambda from both the numerator and the denominator, and that finally leaves us with C over A minus B. So this is the expression on the right hand side. So hence we have successfully showed that by using the law of sines, this equation is true.